In this video, I'll explain how to use collect framework in Java streams. So Java streams has source. Source is nothing but your like input list of objects or input list of strings or any source of like stream objects. Okay. So what we are going to do is we are going to operate on this collection objects and then apply a filter or map in the intermediate operators. So if you look at this diagram, so we apply, say for example, if you have a list of movies, we apply like what are the movies released on like 2021. So we can apply filter and map on that. So I've gone in detail about this filter and map in the previous videos. So check out those if you haven't done that already. So this one, I'll focus more on the terminal operator. Okay, so once you have a list of objects and then you applied some filtering or mapping logic, so what you have to do is you have to apply a terminal logic. So terminal logic is nothing but you're collecting the data what you filtered into a list or into a different type of objects. So there are different ways you can get it. So the collect is nothing but a framework within like Java streams. So it is one of the terminal operator. It's not the only one. So there are other terminal operators like for each. The collect is one of the like commonly used terminal operator. So I'll show some examples on how to use collect in the Java streams using collectors utility class. So collectors is nothing but a utility class provided by Java by default, which has some implementations to use collect. Collect is nothing but an interface in Java streams. So as you know, like any interface, you need an implementation class for that interface. So by default, Java streams provide a implementation for collect, which is called collectors. So collectors has bunch of implementation on how to like say convert a list of objects to a string or to a list or set. There are different implementations. So we'll see some examples at the end of the video. So if for now, you can imagine collectors as a list of default implementation provided by Java streams. This doesn't mean that you cannot use your own implementation. So we can also create a custom collectors to uh, return this collect interface type so that you can use it in the streams. So uh, typically most of the implementations are readily available in collectors framework. It is recommended to use one of that. If it is not available, then you can go for the custom implementation. So let's go to the Java doc and see this interface. What is the contract of this interface? So this is the interface, collector interface, which I'm talking about. So uh, the collector interface takes in like three type parameters. Like the first one is T, which is the type of the input element, so which is nothing but the list of objects or the stream objects which we send for the streams API. So it could be a list of movie objects or anything. So A is the accumulation type of reduction. So which means that so let's say you want to get only the movies released on 2021. So you apply filter and map. So you accumulate into the intermediate object somewhere. So it's part of the implementation. You don't have to worry too much about it. But this is the intermediate object where we accumulate the results. And R is the final results object. So which will let's say we want to convert those list of movies into a list of strings. So list of string is that result. So the output for that entire stream operation is what comes out of the result. So you can, as far as you have the implementation which supports this collector interface, so you can use that in Java streams. So now this collector interface, so we need to have some sort of implementation for this collector. So do we need to really implement it ourselves? No, there is a set of implementation provided by default in the streams framework. Okay, so if you look at this class collectors, so there are a lot of implementation methods available. So For example, the first few set of methods are like scalar operations, which is nothing but averaging and all that. And there are some grouping by. So grouping by is similar to SQL group by functionality. And so there are a lot of methods. We'll look into the examples in the end of the video. I'll demonstrate some of the methods in this. So one thing which is common in all those methods are like everything returns collector interface. So this is critical because this is how the Streams API accepts this implementation. So as far as it returns a collector interface, you can use it in Streams API to use this implementation. So that's the whole point of this implementation class. So to return collector interface. So the signature of the collector would be a little different based on what type of implementation. For example, the counting here returns like a list of elements in the string. So if you look at that, it returns collector, but the list, the return type, the third type parameter we are returning, that's a long data type. So that represents the number of elements in the uh, list of objects. Okay, so that's a each that's why like each and every return type, even though it is a collector, it has a different type parameters to match the implementation. I've already mentioned, so the collectors implementations is to support the collect interface, which is used in the Java streams. Let's move on to a demo for this collect framework. So for this demo, let's imagine we are working on a movie streaming type of application like Netflix. Okay, so in this application, so we are going to cover like set of requirements to implement. The first requirement is like the get a list of movie names and add it to a list. Okay, so given a list of movie objects, let's say you call a database to get like list of movie objects, and then we want to display only the movie names on the page. So how do we convert that input movie list object list to just a movie names list of strings? Okay, so using this collect framework. So I'm going to like take a list of movie objects and then convert that to a list of string. So let's see how we can do it in collect framework. So I opened STS and I've already created a Pojo, like a simple Java Pojo, which has the movie object. So movie object, as you know, as you can see here, it's nothing but just a name, a date of the release year of that movie, actor, who's the actor on that, and the rating of the movie. So just a four simple fields and all the getter and setter for this fields. So let's go ahead and create a new class to um, write some streams. So I'm going to call it as say Java like okay streams collect demo maybe, yeah, and just public select void main and finish it. So in here, so what I'm going to do here is uh, to demo this, I'm going to create a list of movie objects. So typically the movie objects could be coming from an API or a database backend. So to make it simple in this for this collect demo, I'm going to hard code those values. So here I've just copy pasted like a list of movie objects. I'm using arrays.asList to create a new movie objects. So there's nothing complex here, just hard coding bunch of values. So if you see that this movie 1, movie 2, and movie 3, I've added like 3 movies, and the first movie is released at 2021, and a second movie and third movie 2020. So our requirement is here to get that movie names. So the movie 1, 2, 3, those are the movie names. So I need to get that in a list of strings. So if you look at it, I've created a list of movie objects. So I need to convert, my goal is to convert that to list of strings using this collect framework. So this movie list dot stream, if I just do this movie list dot stream, it gives a stream of movie list objects. Okay, and then I'm going to use map to map the movie names. Okay, so movie, if you use the double colon get name, which means that we are using the lambda expression, or this is equivalent of lambda expression. So this is nothing but a method reference way of using lambda expression. So I've explained the details of like lambda expression and everything in a different video. If you haven't watched it, check it out. But here, what I'm doing eventually is like in the list of movie objects, I'm taking out only the movie name, and then I'm going to collect those names in a something called a collect object. So when I say dot collect, so if you see this, there is a collector is the argument that need to pass. So collector is nothing but an interface, as I explained in the previous section of the video. So this is an interface. We need an implementation for that. So the implementation is nothing but the collectors class. Okay, so collectors, if I do collectors dot, so there are like a lot of methods as we have seen in the our doc before. So the one which I'm going to use is in this scenario, I'm going to use the toList method. Okay, so toList, what it does is it just converts this list of movie names, what we are mapping, into a list of strings. Okay, so if you look at the return type for this collect call, it returns a list of strings. Okay, so now all I have to do is to assign it on the return type variable and print it out. Okay, so it's that simple. You just have one line of code to implement that requirement. So I'm just going to collect it as a list of strings and just call it as a movie names. Okay, so that's all. Like our requirement is pretty much done. So I have a list of movie objects and I've converted to a list of strings of movie names, just the movie names. I can just print it out now by using a sysout just to run this program. Okay, let's okay, so I just copied for to save some time. So movies named are for each. I'm just iterating and printing it out. Okay, let's run this and see if it works. So if you see this, all the three movie names are printed. So I've used collect framework here using collectors. I'm collecting all the movie names and just printing it out. Okay, that's all. Our first requirement is done. So this is how we can use the collect framework. So let's move on to the next one. We'll move on to the next requirement. So the next requirement, let's do the same like list of movies. Instead of adding it to the list, we are going to add it to set. So the set behavior is in the collections framework, set doesn't allow like duplicates. Okay, so if you have a duplicate movie names, it's going to uh, ignore the duplicates and just list down only the unique values. Okay, so here what I'm just going to copy this exact same code and paste it here. So the syntax and everything is same. So we are iterating through the movie list stream, and instead of list, we are just going to say toSet. Okay, so it's obviously it's going to return like a set of movie names. So that's all we need to do. Like I'm just going to set it as a movie name set, and we can print it. Okay, so just importing this set, just a Java util set. And so if you see here, there are three movies. So let's see what happens if I run this. So movie 1, 2, 3 is all getting printed because there are no duplicates. Let's say if I have a duplicate, we just copy paste this and add the movie 3 again. So it doesn't matter about the other attributes. So I can give the movie name as same or different. Um, so the movie name is the one it looks for. So to identifying whether it is a duplicate or not, because that's what we are mapping in that stream. So we are filtering that movie name. So it looks for that movie name. So let's comment it out and try to run this with list and see what is the behavior first. So list displays all the elements here. So it doesn't matter whether it is duplicate or not. So let me comment it out and run the set behavior. So set behavior, my expectation is it should display only movie 1, 2, and 3. Let's run it and see. Yeah, it displays 1, 2, and 3. So the fourth movie, which is the duplicate of 3, that will be ignored because of the set behavior. It's nothing to do with the streams as such. So it's the behavior of the collections framework. Okay, so just a different ways of like collecting the uh, collecting a list or set based on your requirement. So if I run this, it'll just say like all the four movies because I changed the movie name. Let's move on to the next requirement. So our next requirement is to join all the movie names with a comma separated values. Of course, we can do that by just using string utils or something, but we want to do it using streams API. So here we have like three movie names. Our requirement is to just say movie 1, comma movie 2, comma movie 3. So how do we do that in streams using streams API? So in streams, we have something called joining. Okay, so we can use the same collect framework, and I'm just going to copy this to save time. And collectors dot joining. So there are a lot of methods in here. So this is the one. Joining is the one I'm going to use for this requirement. To this is if the argument which expects is the delimiter. So you can use comma or any other character to join these names you're like mapping to. So we are in the stream. We are getting the name of the movies, and then we are using collectors dot joining to append comma separated values for all the movies. So it's that simple. So you don't have to iterate through all the list and add the comma with like a string utils or something. So I'm just going to save it as string movie names. So if you just print it out, you'll see like movie 1, comma movie 2, comma movie 3. Here I'm going to store this in a variable called all movies, and you can just print out this to see what is the result of this. So before we print it out, so if you look at this, all this collect methods, it has a specific return type. So that's returning list, and the previous one we were returning select. So how does all this return type being decided? Okay, so if you remember like the API documentation we have seen in the initial part of the video, so each collector interface has a R as a return type. So R is the type of the object it is returning. So every implementation class, so the collector's implementation class toList or toSet has a specific return type which is mapped to that R generic type. Okay, so that's why you see a different return type for even each and every like operations we use in collectors. So even though it is just a one collect method we are calling, so it basically returns a different type of objects for every scenario. So the joining returns just a string. So and then the other, if you look at the like collectors framework also, there are a lot of implementation. I'm not going to go through the implementation details of it. It's part of the streams API. If I want to check like say toSet, how it is implemented, feel free to just to check out this implementation if you're curious. So this is the toSet implementation. So if you look at this, they are like iterating through and trying to get that converted to a set. Whatever list we are, the list of objects we are sending, they're trying to convert to a hash set and then returning as a set. So that's the implementation details that we don't need to worry about. So just go through this documentation of the interface to try to understand like what everything means, and then collectors documentation also helps. Okay, so here for now I'm just going to print it and see what is the output for this scenario. Okay, so let's say sys out.println all movies, and then if you run it, it should print all the comma separated values. Okay, here you go. So movie 1, comma movie 2, movie 3. So this is how we use like a joining in collectors framework. Just feel free to try out the different operations. So we've covered like list, set, and then joining functionalities. And then now the fourth requirement we have is a group movies released in a year of release. Okay, so let's say we have like three movie objects. So I want to like get only the movies released in 2021. So how do we do that? How do we do the group by operation? So here are the movie objects we have. Like we have three movie objects. One is released in 2021, and the second one is released in 2020, and the third one is released in 2020. So a requirement here is to get movies released on say 2021. So I want to print only the first object. Okay, or if you go with the requirement of 2020, then I need to print the second and third. Okay, so how do I implement it in collect framework? So what we are going to do is we are going to use something called joining in collectors. So as I've explained before, collectors has like a lot of implementation. Let's see how we can use it. So what I'm doing is here is extreme.collect, and then so before I do the actual operation. Let's write down like what we are doing here. So to group movies by year of release. Okay. So here, so group by, there is something called collectors dot group by. So this is the method I'm going to use. So group by, if you look at this contract, it takes a functional interface, so which is the Lambda expression. So here, what is our logic here? So I want to group by the year of release. So every movie object has a year of release. So I need to use a Lambda expression at this point to get that year of release equals or like uh, equals 2020 or equals 2021, whatever our requirement is. So here you can do this Lambda expression given a movie object, you can just do the get year of release, or you could just do this uh, functional method reference. It's just both are same. So movie double colon get release year. So this is nothing but a Lambda expression, different way of writing a Lambda expression. So using method reference. So here, this what this does is this gets the release year. So it groups that release year and then puts it in a collection, two different collections. Okay, so whatever the release year uh, it is in the set of data. So let's say we have like three movie objects, right? So two movie objects will go into one list and the remaining one will go into the other list. Okay, the return type, if you notice that return type, that's how the return type is. It's a map of so it gets the integer comma list of movie objects, right? So integer is the year of release. So whatever like we are grouping by, so that is the key map is nothing but a key value pair. So you have the key as the uh, grouping by element. So in this case, year of release is the key, and the value is the list of movie objects here. So on the top, you have like, so two movie objects would be in one list, and the other one would be in another list. Okay, so the two keys, if I have to tell you the keys, it's 2020 and 21. So this is the map of integer comma list of movies. Okay, so 2020 is one key and the 2021 will be another key. Each key will have a list of movies. Okay, let's you'll understand once I print it and show you like what's going on. So the important part is to understand this list here, and then what is the key for that movie object. So key is whatever you're grouping by, and then list is the based on number of elements that key matches to. Okay, so let's try and print this and see if you can. Uh, so this is just a way of printing. I'm just copy pasting it. So movie map list for each. I'm just iterating each element in the map, and then key value pair. I'm just printing the key value pair. So as I mentioned, key would be here the year of release. Let's run it and see. So I'm just going to comment all the other noise here. So my expectation is it should have like, yeah, two keys. One key would be 2020 with like two movie objects. So if you notice here, the movie 2 and movie, I think I have to scroll that side. So movie 3 would be in the first list. And then the second the second entry in the map is 2021, which has the movie 1. So that's how it splits or groups by. So this is similar to SQL group by. So if you have used SQL, so it's no different than this what we are doing here in streams. So it's much easier way than like iterating through each element and finding out like which matches the year. So here I have a toString method just to see print it in a nice way. So you can format it differently. So just to see what are the elements in the movie object, okay, movie pojo object. Okay, so I think that pretty much covers this requirement. So it's pretty handy to have this group by. So if you have a requirements to say, for example, movie streaming applications have like genres, different genres, like action movies too, you can just split it in one group, and the other movies you can just split it in another group. So those are some practical examples you can think of for the group for using grouping by. So let's move on to the next example. So here, next one, we are going to see how to find the average movie ratings for the list of movies. So this is another like method in collectors framework where we can leverage. It's called averaging. So they are like there are a lot of average functions. We are going to just use averageInt here. So I'll show you an example. So it's pretty similar. So you just do movie list dot stream dot collect. So let me copy paste that. So this is the requirement. Just find the average movie ratings for the list of movies. So here, uh, I'm just going to copy paste the movie list dot streams dot collect. So here in this collectors class, what I'm going to use is the averaging integer. So averaging, there are other functions available, methods available. Just give it a try. But averaging int, what it does is it takes in the toInt function. So here it's a lambda expression again. So we have to get the rating. So the rating is the one we are taking an average of. So all this does is like this is gets all the movies and then gets an average of all the movie ratings. Okay. So that's all. So this function does all the calculation for us and it returns an integer. So I think it returns a double. Okay. So it returns a double. I'm just collecting it in a double and we can print it out. So there are a lot of operations like this in the um, collectors framework. Just give it a try, and we just do in system.out.println and we'll run it and see if it works. So here you go. It prints the average movie rating of all the three movies. So 344 is what I have, and the average is 3.66. Okay, this is how we use the average method in collectors framework. Okay, let's move on to the last requirement before we wrap up the video. So the last one we are going to use something called so partition by. So the requirement is split the list of movies into two separate lists based on a criteria. So let's say we want to like get the list of movies whose rating is like more than 4 and less than 4. Okay, so how do we split the list? Okay, so here in this example we have like three movies and then that out of that two movies has like rating 4 and the one has 3. So I want to take out that two movies, like split the list of movies into two separate lists based on the rating, right? So um, based on the rating, I need to split it. So it's basically, if you think about it, it's just a true false, right? So using partition by. So here, let me explain it. Movie list.stream.collect. Okay. So there is collectors framework has this partition by. So the partition by takes in, if you look at this, it takes in predicate. So predicate is a functional interface which results in a boolean value, true or false. It's like an if condition, if else condition. So if this condition is true, then you split it into one group. If the condition is false, it is split it into another groups. Okay, so here we have to write a predicate lambda expression given a movie object. Okay, so I'm going to get like the rating, right? So all we are doing is we are splitting by like partitioning by rating. Okay, if the rating is greater than or equal to 4, you split all the movies which are greater than or equal to 4 into one partition and less than or equal to 4 into another partition. So the condition is true, greater than or equal to 4. So then the stream would return a same set of like a map. If you look at the return type, so it returns a map of Boolean and list of movies, right? So Boolean is your key. It's similar to the one we saw previously, like integer as a key for group movies by year of list. Okay, here the Boolean is the key and the list of movies is the value. Okay, so in this case, the one difference between grouping by and this is like a partitioning by. Here we'll have only two partitions, right? So we are partitioning uh, by the condition is true or false. Okay, so uh, since it is a Boolean value, there are only two values possible. So the key would be true would have like a list of movies which are like greater than or equal to 4 rating. False would have list of movies which are less than or equal to 4. Less than 4, not less than or equal to. So let's uh, let's print it and see like what it results. So my expectation here is the first, second, and third movies would be in true, and the first movie would be in false map. Okay. So I'm just doing a for each, copy pasting it. So key value pair printing, similar to the one we did before. So let's run it and see the results. So yeah, here if you see key is false. False has the one movie which has rating 3, and the true key has like two movies, movie 2 and movie 3, which has rating as 4. Okay, so this is how it partitions. So partitions based on the conditions. So if I change this to 3, 4, and 5, so still that movie 1 would be in one condition, and the movie 2 and 3 would be in another one. So since it is greater than or equal to 4, so you can just play around this condition and see if you get a different result, just to get hold to understand this partitioning, how it works. So I think that this covers most of it. So just to quickly recap, so we looked at all the collectors. What are the functions available, methods available? So I've covered like probably most of the important ones. So feel free to read this collectors documentation and try out some of the other functions. So it is pretty handy. So most of the common functions we want to achieve using like collectors and streams, it's available right here in this implementation class. So you don't have to write a custom implementation. Uh, but some cases, edge cases, you might have to write some custom implementations. So I would highly recommend going through this and try it out so you till you get comfortable with this APIs, with this collectors framework. I hope you like this video. Thanks for watching, and see you in the next one.